Hello again. We're going to be looking at problem 1 on page 629. This is in section 10.2 of your textbook. And before we do, we need to just get some essential understanding. That's why I want to talk about this up here before we actually do the problem. When we have any kind of a regular polygon, that means it's the same length on all the sides, then there is a circle that can go around any regular polygon. Okay? And the center of the polygon is also going to be the center of the circle. And then if you go from there to the vertex of the polygon, that's also the radius of the circle, as well as if you go from the center out to one of the sides of the polygon, that's called an apothem. Okay? And so there's that word. That probably is a new word to you, but that's an apothem. That means it goes from the center out to the center of the opposite side. And this particular apothem always splits this angle in half. Okay. Now, with that being said, let's look at problem. Let's look at problem number 1 here. Let me pull this down just a little bit. On problem number 1, it wants us to look at this figure over here, of course, and be able to measure or give the measure of the different angles. So let's start with number 1, because number 1 is what we call a central angle, because it's an angle that's at the center. It's the center of the circle that would go around it, as well as it's the center of that particular polygon. And it's very easy to do. You simply, if you want to find the measure of angle 1, you're going to take 360, which is all the way around a circle. If a circle were to go around that, and could, you're going to take 360 and you're going to divide it by 5. Well, where's the 5 coming from? Because this particular figure has 5 sides to it. So 360 divided by 5 equals 72. So the measure of angle 1 is going to be 72. As I shared with you just a minute ago, if we look at the measure of angle 2, which is this little one right in here, remember I told you that the apothem splits all these angles, because not just one, but that angle and that angle and that angle, all these angles would be 72 degrees. So to find the measure of angle 2, you're simply just going to take half of the one that we know, which was angle 1. So it's going to be half of 72, or 36. And of course there's a little arrow because it's so tight in there, but angle 2 would be 36 degrees. Now, that apothem, because that's a right angle right there, that makes a right triangle. So this little area right here is a right triangle. We already know that angle 2 is 36 degrees. We know that this one, of course, is a right angle, or 90 degrees. So remember that the 3 angles of a triangle always have to add up to be 180. So if we add the 90 and the 36 and then whatever the measure of angle 3 is, all 3 of these together should add up to be 180. Well, these two together, that makes 126. If I were to subtract 126 over from the 180, okay, if I would subtract 126 here from the 180, that's where I end up with the measure of angle 3 equals 54. Okay, so now we know this angle, which is 54. We know this one, this little tiny one in here, was 36, and of course that one's 90 degrees. And then the original one, the big one right there, angle 1, was 72 degrees. Okay, now let's check to see if you understand. At the right, the portion of the polygon octagon, and here's a key word, it's an octagon. It's only showing you a portion of it. It's not the whole thing, but it gives you this word right here, which is very important. It has radii and an apothem drawn. What is the measure of each numbered angle? Again, angle 1 over here on the side is just like this angle 1 was here. It's the whole angle. So if I were to take 360 and divide that by 8, because that's what an octagon is, okay, 360 divided by 8 on this particular problem ends up being 45. Is that correct? Let me get my calculator real quickly. If I take 360 and divide that by 8, I do end up with 45. So this whole angle right here, angle 1 would be, the measure of angle 1 would be 45. Okay. Now, on the other one, again, angle 2 is going to be half of that because of the apothem. So if I were to divide 45 by 2, of course, that's going to not come out even, but you're going to end up with 22.5. And then, for the same reason, to find the measure of angle 3 down here, this is a right triangle here. So if I know that one of the angles is 22.5, of course the other one is 90, what else would the measure of angle 3, those three angles would have to add up to be 180. So 90 plus 22.5 is 112.5. If I were to subtract that from the 180 minus the 112.5, I would end up with 67.5. So that means this angle right here is 67.5. Okay, I hope that was helpful. Best of luck.